All right, I'm Robert Mercado,
I'm Paulo Dorado.
and today we're going to be talking to you about our autonomous search and report system. Our project introduces solutions to issues related to high-risk situations. For example, recon and patrol in the military are very commonplace, but people who do that kind of work are at high risk. Another example would be people who do search and rescue after a major destructive event or natural disaster. They have to go through and dig through rubble, and that stuff is dangerous. So we're proposing a solution to that. We can put robots out there when instead of putting humans at risk when they don't need to be.
The most challenging part of this assignment was figuring out how ROS works. We looked at articles, Q&As, and forums to help us with our project, but because ROS is poorly documented in our scope of our project, a lot of them failed, had errors in it, or is meaningless to our project, like it didn't help us at all. Another problem that we had was the namespaces. So when we instantiate two separate machines, we need two different environments, and that's what namespace is used for. But because some of the modules that we use in our program didn't really support having namespaces in the program, it crashed our whole entire program, so we had to scratch out the idea.
All right, so in our project, there were numerous utilities and libraries that we reused that were already part of an existing system that we just adapted for our own. And some of those were ARPose, which is our vision stand-in, which detects markers and is very simple. And our move-based and simple action clients, which helped our robot go to target locations and provided a trajectory planner. But some of the things that we did create from scratch were our machine communication and a simple turning algorithm, and also our patrolling sequence.
The largest problem that we face in our project in regards to fundamental problems in autonomous robotics is vision. We used ARPose as our component to simulate vision, but our approach to it was impractical because with ARPose we used a marker that the machine would detect using its camera. It's impractical because there's no markers laying around for the robot to detect. So it's the best that we could do in the modules that we had to use, so we made use of it in our project.
If we had more time to work on this project, we would implement our communication as UDP packets. This would circumvent the problem that we were having with namespaces, and it would allow us to expand our project to include more robots. So there's a possibility of having swarms of robots doing these actions together. So you have swarms of robots doing search and destroy or search and rescue. I'm Robert Mercado, and this is our robot in action. First, we run our launch files for our Scout and HQ system. Then we localize the robot to a starting position of our choice. Our robot will then go to numerous goal points in a pre-existing map that we give the robot. At each goal point, the robot does a 360 while scanning the area. If it finds a marker, it will go to that target and then go back to base. Upon finding the marker and going back to base, the user will be queued that something has been found. If nothing has been found, then the robot will continue to each goal point until it's gone to every point, then go back to base, and it will then let the user know that nothing has been found.